Hello everyone, this is Poonam. This is the fifth part of the video, chapter 10, electricity chapter. Today we are going to discuss the topic resistance. Resistance is the property of the conductor due to which it opposes the flow of current through it. Means when the current will flow through the conductor, then there will be some opposition which is called the resistance. When electric current passes through the conductor, then electrons starts moving and they collide with each other because of the kinetic energy, and there will be the production of heat. Resistance is equal to potential difference upon current according to Ohm's law. So R is equal to V upon I. The unit of resistance is ohm, which is denoted by the symbol omega. We have R is equal to V by I. So R is 1 ohm when potential difference is 1 volt and the current will become 1 ampere. So when potential difference is 1 volt and the current of 1 ampere flows through the conductor, then the resistance will become 1 ohm. The symbol of the resistance is just like the zigzag pattern because of the opposition of the flow of current. Just like the speed breakers which are present on the road, they slow down the speed of the vehicles. This resistance helps to slow down the flow of current. Now, what are the factors on which this resistance depends? Resistance depends upon the 4 factors: length of the wire, area of cross section or the thickness, nature of the material, and the temperature. The first is the effect of length. Resistance is directly proportional to the length of the conductor. More the length, more will be the conductor; less will be the length, less will be the resistance. Next is the effect of area of cross section. This resistance is inversely proportional to area of cross section. If the area becomes double, then R gets halved, and if the area gets halved, then the resistance gets doubled. If there is a thick wire, then thick wire has the less resistance than the thin wire. That's because of this reason the electrical transmission wires they are very thick wires and they are not the thin wires. The short length and thick wire has low resistance, and long length and thin wire has high resistance. One more point to note down, that this resistance is inversely proportional to square of the diameter. If the diameter is 1 by 2, then the resistance becomes 4 times, and if the diameter is 3 times, then the resistance becomes 1 by 9. Just like R is 1 by 3 square, this diameter is 3, so 3 square, 3 3s are 9. Next is the nature of the material. If the nature of the material is a good conductor, means the material is good conductor, then there will be less resistance, and if the material is an insulator or poor conductor, then the resistance is high. Next is the temperature. Resistance is directly proportional to temperature, means when the temperature will become more, then the resistance will become more, and when the temperature is less, then the resistance will be less. Next is the resistivity of the wire or resistivity of the material. We have the two formulas. R is directly proportional to L and R is inversely proportional to A. By combining these two, we get R is directly proportional to L upon A. And by removing this sign, proportional sign, we get the symbol rho. This R is equal to rho L upon A. And this rho is the resistivity of the conductor, or we can say it is the specific resistance. This rho is equal to R A upon L. This rho A को हम इस तरफ लेके जाएंगे, R into A, and L जब लेकर आएंगे इस तरफ, तो it will become in this position. If the area is 1 meter square, this area is 1 meter square and the length is 1 meter, then we get this 1 and 1 will be cancelled out, and we will get rho is equal to R, or the resistivity is numerically equal to the resistance if area is 1 meter square and the length is 1 meter. Now the unit of the resistivity, this rho is equal to RA upon L. The unit of resistance is ohm, area is meter square, and length is meter. So from 1 meter, this 1 meter will be cancelled out. So we get rho is equal to ohm meter. These are the some points to keep in the mind, that the resistivity does not depend upon the length or the thickness of the wire. It depends upon the nature of the substance and the temperature also. Good conductors have low resistance and the poor conductors have high resistance. That's because copper and aluminium wires are used for the electrical transmissions, because these two, they have very low resistivities. But from this copper and aluminium, this silver is very good conductor, or we can say best conductor of electricity, but we are not using silver for electrical transmission due to its high cost. So this is all about the topic resistance and resistivity. In the next video we will discuss about the numericals of the resistance and resistivity.